Hello and welcome to the course of network security. This is another topic which is important. In the previous lecture, we studied private key encryption. In this lecture, we are going to study public key encryption, or it is also known as asymmetric encryption. We are going to explain this concept with the help of a briefcase protocol, and then we will also see an advanced version of the briefcase protocol. Let me first explain what is asymmetric encryption. If you remember, symmetric encryption is a type of encryption in which we actually use a single key both for encryption as well as for decryption. And that single key must be kept secure. It must be only known to the intended sender and receiver. On the other side, asymmetric encryption, it is actually alternative of symmetric encryption. This type of encryption is also known as public key encryption. Instead of using a single key which is shared by the two participants, a public key encryption or asymmetric encryption uses a pair of related keys. Two words, pair and related. The keys must be related to one another, and every participant has to use two keys, a pair of keys. One key is used for encryption while the second key is used for decryption purposes. It means that every participant has to own two keys. The owner keeps the decryption key secret, that is the whole secret, so that only the owner can decrypt the message. And that key which is kept secret by the owner is known as a private key. So that is the whole story. In asymmetric encryption, we actually need to use two keys, public key and private key. The public key, you can share it with the public, while the private key must be kept secret by the owner of the message, or it must be known only to the person who is actually able to decrypt the message. You will use private key to decrypt the ciphertext or derive the plain text from the ciphertext. To better understand the concept of asymmetric encryption, let us consider a briefcase protocol. In this case, we have two participants, Alice and Bob. Alice wants to securely send a message to Bob. Suppose that Alice wishes to send a secure message to Bob, whom she has not met before, and with whom she has no previous trust relationship. As this is going to be a physical message, Alice will secure the message by locking it into a briefcase. By secure, we mean that we want to make sure that nobody can see this message during its transmission over an insecure medium like internet. As Alice has not any previous trust relationship with Bob, we assume that Bob does not already share a key with Alice. And the whole process is depicted in this picture. As you can see, the two parties are engaged in a secure communication with the help of a briefcase. In step number 1, Alice begins by obtaining a padlock, and only Alice has the key to this padlock. Alice places the message into this briefcase, locks the briefcase using the padlock, and hands the locked briefcase to a courier who transport it to the Bob. Bob will obtain a padlock of his own. Once Bob received the briefcase, he add the second lock to the briefcase and return the briefcase to the courier, who take it back to the Alice, and it is happening in step number 3. Now we have two locked placed on the briefcase. Once the briefcase arrived at the sender side, Alice will remove her padlock and will hand over the briefcase to the courier again, who can again transport it to the Bob. At step number 5, Bob will remove his padlock and open the briefcase to obtain the message. Now the briefcase protocol achieves our stated goal because the message is kept confidential throughout its 3 journeys between Alice and Bob. Since the briefcase is always locked by at least one padlock belonging to either Alice or Bob, so we can achieve that goal. Although this version secure a physical message, it is possible to produce a cryptographic equivalent of the protocol, which is known as the briefcase protocol. So the briefcase protocol shows us that it is possible to exchange a secure message between two parties who have not previously established a secret key or who have not established a trust relationship before. However, there are two major problems with this briefcase protocol. And the problems are related with authentication and efficiency. Authentication, lack of assurance that we have indeed securely communicated with the entity that we think we are communicating with. How Alice will make sure that she is actually communicating with Bob, or how Bob will make sure that the briefcase is indeed arrived from Alice. So authentication is a problem. Second problem is efficiency. The briefcase protocol involves three journeys, or you can say three passes of the briefcase between Alice and Bob. So efficiency is another issue with this simple protocol. So we need a better version of this protocol. Here we have a better version. Suppose Bob now obtain a padlock and somehow gets the padlock to Alice. He could either send it to Alice or he could distribute thousands of copies of the padlock around the world so that Alice can easily acquire one when she needs it. Alice will now lock the briefcase using the Bob padlock and send the locked briefcase back to Bob, who then unlock it using his key and obtained the message. Now Alice will face two challenges. First, she has to acquire Bob's padlock, and for that two solutions are possible. Bob can send the padlock, a copy of the padlock to her, or maybe she can obtain a public padlock from anywhere, because that have been distributed by the Bob in advance. The second unique challenge faced by Alice is that Alice has to be sure that it really is Bob padlock that she's using. This enhanced version of the briefcase protocol leads us to the idea of public key cryptography or asymmetric key cryptography. It was initially introduced by it was initially invented, you can say, to overcome some of the problems that happen with symmetric key cryptography. What was those problems with symmetric key encryption? In symmetric key encryption, as we saw in the previous lecture, to share the same symmetric key, the sender and receiver must need to trust one another to an extent. Consider the example of an online store. For example, the customer browsing the store for the first time has no reason to trust the store. Sender and receiver need to agree on a symmetric key in advance, because in symmetric key encryption the only secret is the key. So you must need a secure way, a secure channel, a secure band for sharing the key with both the parties. Unlike private key cryptography, keys are not shared in public key encryption. Instead, each individual has a pair of keys, two keys. A private key that need to be relevant to anyone, and a public key that is preferably known to the entire world. The public key is normally used for encryption purposes, and a corresponding private key is used for decryption purpose. Anyone who has a public key can only encrypt information but cannot decrypt it. Means for decryption you need the private key, while for encryption purposes you can use the public key. Only the person who has the corresponding private key can decrypt the information. So let me summarize things. In asymmetric encryption, we will use two keys, public key and private key. Public key is used for encryption purposes, while the private key is used for decryption purposes. Public key is not required for the public key to be secret, while the private key must be kept secret. And the whole process is depicted here. We have a sender and receiver. Sender is interested to send the plain text by using an insecure medium toward the recipient. The sender will decrypt the plain text. He will convert the plain text into ciphertext by using an encryption algorithm along with a public key. This public key is used only for encryption purposes, and then he or she will send the ciphertext over the insecure medium. At the receiver side, the receiver will use his or her private key to decrypt the message or convert the ciphertext back into the plain text. So while symmetric encryption uses a single key both for encryption and decryption, asymmetric encryption uses two keys. But remember, these keys are related with one another. I said that you can use the public key for encryption and private key for decryption. But that is not always the case. Either key can be used to encrypt or decrypt the message. However, if key A is used to encrypt the message, only key B can be used to decrypt the message. Or alternatively, if key B is used to encrypt the message, then only key A will be used to decrypt the message. In short, the same key cannot be used to encrypt and decrypt. Asymmetric encryption can be used to provide elegant solutions to problem of secrecy and verification of messages. Let us consider an example of asymmetric encryption. We have Alex at XYZ Corporation, and she wants to send an encrypted message to Rachel at ABC Corporation. Alex goes to a public key registry and obtain a Rachel public key. When Rachel public key is used to encrypt the message, only her private message can be used to decrypt the message. The private key is held by Rachel alone, and similarly the other way. So you can see the public key is used here for encryption purpose to encrypt the message or convert the plain text into ciphertext, while at the receiver side you can use the private key. The private key can be used to decrypt the message. So you can see here he want to send a message to her colleague. He will encrypt the message by using a public key, and then she would be able to decrypt the message by using her private key. So you can see we are using two keys here. One is the public key and one is the private key. The public key B is used for encryption purpose, while the private key is used for decrypting the message. This is about the asymmetric encryption, and the primary benefit of public key cryptography is that the need for sender and receiver to share the secret keys by using some secure channel is eliminated. Some examples of the public key encryption are RSA algorithm and DSA, a Diffie-Hellman and digital signature algorithm. We will see those algorithms later on in this course. Thank you so much for watching the video. Take care and goodbye.